Good evening, Robert Scribbler. It is August 31st, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I'm going to talk about one greenhouse gas that I monitor through the use of various global monitors, and that is methane, and in particular, where we are seeing high levels of surface methane, which is indicative of surface methane emissions from various sources. Now, it's worth noting that methane is a more complicated greenhouse gas in some respects than carbon dioxide. It comes from various sources, but it's also worth noting that the primary source of the increase in atmospheric methane since the start of the Industrial Revolution has been the result of human activities, primarily including fossil fuel extraction, natural gas and coal in particular, as well as changes in land use, which have increased methane flux into the atmosphere from human sources to include farming. Now, it's also worth noting that there's a feedback component for methane, is that as the Earth warms, there tends to be more drought in certain regions, or precipitation patterns change in certain regions, or you end up with permafrost thaw in certain regions. And so, as the Earth warms up more and more, you can tend to get a bit of a feedback signal from methane in regions that were traditional carbon sinks that begin to bleed out a bit of carbon. So I also just like to add a caveat to this discussion. The methane discussion is also often charged with doomerism. I want to avoid that charge as much as possible and just look at the facts of the present situation and not speculate about potential low probability but high impact scenarios that tend to get people looking at the climate situation, in my opinion, in a rather inaccurate fashion, because people tend to hyper-focus on the worst case scenario. When we're looking at threat, we want to look at the range of scenarios as it relates to present reality and present tracking. And so you don't ignore the worst case scenario, but that's not the only thing you look at if you're going to do an accurate threat assessment. So with all that in mind, I'm going to just show what we've been showing, this graphic of surface methane concentrations provided by the Copernicus Observatory and its atmospheric monitoring service. And what we see is that there are elevated levels of surface methane in a number of regions. In traditional oil and gas extraction regions such as the Middle East, high levels of oil, gas, and coal burning regions such as China and parts of India. But there's also likely an additional signal in this, because we're getting high surface methane concentrations over the Himalayan region and over areas that are not highly industrialized, which might be an indicator of a surface impact due to there's been quite a bit of rain in this region recently, so that there might be a surface impact due to the high levels of rainfall and wet soils produced in this zone. It's also worth noting that the highly industrialized regions of North America showed quite a bit of high surface methane concentrations. Now, I'd just like to call your attention to this band in the tropics with rainforest regions having high surface methane concentrations, as well as areas where we've seen a lot of wildfires in the tropics recently as well. Moving north, we also find a rather large methane plume flaring through central and eastern Siberia And this may be an indication of the impact the Siberian wildfires are having on methane emissions in this zone, and that overall the methane levels appear to be relatively heightened over the Arctic Ocean zone. So just a general assessment of where present surface methane levels are high. I'd like to also just provide some more context as it relates to present rates of atmospheric methane increase in methane concentration. But before I get into that, I'd just like to provide you with a comparison of the relative amount of greenhouse gas forcing gain since the start of the Industrial Revolution from methane versus CO2, which is the primary driver of human-caused climate change. CO2 presently amounts to about 2 to 2.1 watts per meter squared of the present greenhouse gas radiative forcing, whereas methane amounts to about 0.5 or 0.6 watts per meter squared. So just to be very clear, methane is the number 2 contributor to the present climate crisis. The primary driver is carbon dioxide, which mainly the heightened levels of carbon dioxide that we see in the Earth's atmosphere is primarily due to massive volumes of fossil fuel burning. Now, overall, methane has varied a bit more than carbon dioxide in its rate of accumulation in the Earth's atmosphere since the 1980s, and it's worth noting that the 1980s through the 1990s saw very high rates of atmospheric methane accumulation that have not been matched since that time, with atmospheric methane rates of accumulation slowing down considerably from the 1990s to the mid to late 2000s, and then starting to ramp up again. And this increased rate of atmospheric methane accumulation coincides with a few signals that we've seen. One from industry, in that we've seen a much higher prevalence of natural gas fracking, which is a high methane emission intensive process. We've also seen a bit of a carbon feedback signal coming from the tropics as the tropics have warmed, and some of this carbon feedback has been in the form of methane. And the third signal is that the Arctic, as it has tended to thaw and as permafrost has tended to thaw, we've seen certain regions emitting more surface methane through such features as thermokarst lakes, or just through soil changes, and possibly through some changes that have not yet been verified for shallow ocean zones. So it's worth noting that the present atmospheric rate of accumulation is slower than during the late 1980s and 1990s, but that it has been rising recently, and it's a bit of a concern. But we don't see catastrophic or extraordinarily rapidly accelerating rates of atmospheric methane accumulation as some of those who point to some of the worst case climate change scenarios have hinted at, and that is a bit of a misnomer. So just a general overview of the present atmospheric situation as it relates to methane, and not taking into account the various debate over worst case climate scenarios, but just taking a snapshot of the present time. Thank you for joining me, and I'll be chatting with you soon.